This is the second part of the lecture on weathering. Last time we were talking about the first type of weathering, which is mechanical, and sometimes we call it physical or mechanical weathering. Today we will be talking about chemical weathering. And chemical weathering usually includes changing in chemical composition or the composition of minerals which form rocks. So we can define chemical weathering as a decomposition and disintegration of rocks due to chemical reaction. And whenever we have chemical reaction, we have water. We keep that in mind. So water causes a change in the chemical composition of rock. Types of chemical weathering are carbonation, hydrolysis, hydration, oxidation, and solution. These types of chemical weathering, such as solution, which is dissolution of soluble particles and minerals from the rocks, oxidation, which is reaction of atmospheric oxygen to form oxides, and carbonation, the reaction of carbonate or bicarbonate ions with minerals. Hydration, which is a process of hydration, is related actually to the addition of water to. Okay, let's start with the chemical weathering on carbonation. And carbonation is a process by which carbon dioxide and rainwater in the surrounding environment react to produce carbonic acid. And all of us know that carbonic acid is a weak acid. Weak acid is not a strong acid. Can you give me an example of strong acids? Yes, strong acids like HCl, like sulfuric acid. But this acid, carbonic acid, is a weak acid that reacts with carbonate minerals in the rock. And this type of weathering weakens the rock and removes chemically weathered materials from the top of the rock. And you can see those equations. Carbon dioxide plus water gives us carbonic acid, and actually one of the rocks like limestone, for example, calcium carbonate, reacts with this weak acid to form calcium bicarbonate. Okay, so the final output here, or the final result, is calcium bicarbonate, and the input is limestone. So these are two different types of rocks chemically changing. Okay, chemical weathering, the second type of this is hydrolysis. And hydrolysis is a chemical reaction between ions of hydrogen and ions of hydroxide in water and the minerals in the rock. The hydrogen acid in the water react with the minerals to produce weak acids again. The reaction in this case creates new compounds which tend to be softer and weaker than the original rock. Hydration. Also, we can define this process where the mineral structure in the rock forms a weak bond with H2O, with water, which causes mineral grains to expand. Their size will be more, the volume will be more, creating stress because they have a bigger size, bigger volume. The stress causes the disintegration of the rock and produces a new mineral compound that is larger than the original compound. Not only changing chemical composition, even here changing with in volume and size. The increased size expands the rock and can lead to decay. Hydration can also lead to color change in the weathered rock. Good example of hydrolysis, anhydride, which can absorb two water molecules to become gypsum. Oxidation. And oxidation, all of us know that when oxygen reacts with elements, we get oxides. So it happens when oxygen and water react with iron-rich minerals and weakens the structure of the mineral and forms oxides. And during this oxidation, we will have change in colors also, not the composition only, but colors taking on like a rusty or reddish orange appearance when we have this in iron oxides and hematites, for example, as you can see from this picture on the right side. Solution. Solution means you have some minerals that when you put them in water, they get dissolved easily. Solution happens when minerals in rock dissolve directly into water. And most of these solutions happens on rocks containing carbonates. They can easily dissolve, such as limestone, but also can happen to other rocks where that they have a large amount of halite. Halite is the NaCl. Third type of weathering is called biological weathering, and from its name we can tell that it happens by factors of biology, human, animals, plants, stuff like that. So the action of plants and animals leads to breaking the rocks. What kind of actions are these? Roots cause disintegration of rocks. Yes, because roots expand in the ground and they push the rocks apart, creating cracks. Roots of trees penetrate into the cracks of rocks and expand them. The types here of biological weathering are burrowing animals, the animals that burrow, and quarrying, make quarries, digging, and human exerting. So the disintegration or decay of rocks and minerals caused by chemical or physical agents of organisms called biological weathering. Organic activity from lithium and algae, rock disintegration by plant growth, burrowing and tunneling organisms, and secretion of acid. Okay, let us talk about the organism activity. We have some animals that burrow or tunnel into rocks, make tunnels that cause rocks to break down and disintegrate, such as worms and insects. They do that usually, frequently. And this will contribute to weathering, of course. These organisms, such as snails, which they attach themselves to rocks and secrete acids. These acids weaken and dissolve rock surfaces. This is a picture of snails attaching themselves to rocks. Plant roots. This is one of the most common form of biological weathering, when plants penetrate into cracks of the rock, causing the rock to split or break into smaller particles through mechanical weathering. Lithium, algae, and decaying plants. All of this is biochemical weathering. uh, leaches minerals from the rock, causing it to weaken and break down. The presence of organisms growing or expanding also exerts a small amount of abrasion and pressure. So we can see here different types of weathering, they can happen together, not only one type. I mean, sometimes rock can be affected by more than one weathering type at the same time. At the end of this lecture, we will have uh, another or addition or like added type of weathering. We call it differential weathering. What does it mean, differential weathering here? Differential weathering is the weathering coming from different actions or different types, or you can see rates of weathering happening to the rock is different from a weathering rate happen to another rock. For example, weathering rate will not only vary depending on the type of weathering, if it is mechanical or chemical, but also they will also vary depending on the rock material itself. Sometimes the rock uh, is solid or soft, so the effect of weathering will different will vary from one rock to another rock. Some rocks are harder, as I said, than other rocks, and will weather slower than the softer rock. So the difference in the rates of weathering due to different types of rocks and texture and composition, of course, we call it differential weathering. And this is the end of our lecture. Thank you very much and goodbye.